Right, last question. Two parallel plates set a distance of 15 millimeter apart in a vacuum. So the top plate is at a potential of positive 200 volt and the bottom is at negative 200 volt. Copy the figure and draw lines to show the electric field between the plates and show a possible path of the electron as it passes between the plates. Then calculate the magnitude of the force of the electron. Okay, so an electron is negatively charged. So as it goes here, it should go towards the positive plate lah. Okay, so that is the direction, and then we have to draw the electric field. Remember, electric field goes from the positive to the negative plate. Okay, so I can just draw something like this. Okay, semua pun begitu. Okay, so this is the electric field lah. Okay, electric field, and then that is the path of the electron lah. Alright, so that is that, and then we have to calculate the magnitude of the force of the electron. Do we need to calculate? Itu jangan. Okay, so in order for us to calculate the force, electrostatic force, we are going to be using this formula. Right, but we can also use this formula. E here is telling us the charge of the electron lah, okay? So, however, we can't actually solve it without finding the electric field strength first. So how do we find the electric field strength? Is by using the formula given in our lecture notes, which is this one. And then this is going to be, delta V is going to be 200 minus negative 200 over dengan the D here, which is 15 millimeter. Okay, so that is that, and then you'll get 2.67 times 10 to the power 4 volt per meter. Okay, so that is the electric field strength. Then substitute that number into this equation. So this is the electron charge, and then you should get the force to be equal to 4.27 times 10 to the power of negative 15 Newton. Alright, so that is your solution for the last question for this chapter.